screen cut off. Yeah, we're going to talk about the exam today. How exciting. What a welcome back. The lectures have really emptied out. No one's here. It's not even raining. I've heard it's been torrential. Oh, that's a great name. Link this list. I like that. All right. I'm just doing this so I can see how everyone's gone with linked lists. Okay. Shall we begin? Just a quick lull into a false sense of security with that question. Oh, that hurts for the 18th truth. No, linked lists are the way we malloc some new memory, make nodes as we need it. Definitely not fixed size. Okay. All right. I'm sure there's mistakes in these questions. I was very jet lagged when I was writing them. See, everyone's drawing it in their mind. All right. Okay. Okay, we can go through it now, later. Oh. All right. Current is head, which means it's at 3. I is at 0, whilst current next is not equal to null. So I check if the next one's not equal to null. If it's not, then I increase the I, so it becomes 1, and then I move my current to the next one over. So now it's at 5. I check if the next one to it is null. It's not, so I go into it. I've forgotten what I was. Was it 1? Now it's 2. Now it's 2. Then I move over to 6. I'll check again if the next one's at null. It's not. So that means I'll increase the I one more time to 3. Was I at 2 before? At 3. Shh. Okay, great. Then I'll move it over to 7. I'll check if the next one is null. No, it's not. So I'll increase it one more time to 4. And I'll move my current to the next one. And then the next one is null, so I won't go into this loop, which means that my I is going to be 4. Okay. There we go. Wilson Zhang's now off the table. Full stop. Okay, what have we got now? What if there's nothing in the list? What will happen now? Oh, very good. All right, well done. So those pesky edge cases, always thinking about them with linked lists. Okay, next one. Next to really stuff you up. Very good. Well done. All right. Very good. Last few. Looks like linked lists are just awesome. Those of you that are in the YouTube chat, that joke. All right, what's happened? Just devastation, that's what's happening. Okay, Adam is just up ahead. All right, final question. Oh no, the people online enjoy your 20-second questions, sometimes 10 seconds. Ah, very good. Well done. All right, who's going to win this? Woo! Okay, that's a good one. Nathan, and who's coming? I shouldn't have done that whilst it was on first. And it is Adam. Who wants to throw some chocolates? Not me. Who's in the theatre? Oh, not even throwing. All right, I think over here. Hey? You're not functioning. I'm not functioning. I've been on a 15-hour plane ride. There we go. I can see from the chat that we're really in the pun section of the course. So that's a bit exciting. I love a good pun. Okay, when is the assignment out? Oh, assignment's already out. I assume you mean when are the assignment marks out? Is that what you're talking about? Nope, assignment 3. There is no assignment 3 unless you want one. Can write one up quickly for you. Okay, so assignment marks will be released after this lecture. So there we go. Something exciting to look forward to. I didn't want to distract you through this lecture. The marks were actually quite good. So just letting you know that overall. What's a good mark? Well, I mean, you're at uni now. Even 70 is a great mark. So Yeah, you've got to really reevaluate. Well, I was like, my dad's favorite saying was, if you got more than a P, you tried too hard, which is not a very good attitude. Don't go down that route. But you just have to realize that, 75 is a great mark, because that's a distinction. A credit is a great mark, and it just depends how much time you've put in as well. And depends what you want to do. But yeah, people have done well. Okay. I don't usually give the average, because an average is a really bad mathematical measure. It doesn't really tell you anything, because what if you are hanging on one side or the other, and then it just kind of brings down the whole thing? It doesn't really give... Hey? It was actually it was a good spread. Like, it's not a normal curve, but it's a nice spread that is weighed towards the better part of the curve. Okay, so you have had a lovely few weeks with the lovely Tammy doing linked lists. She has done a lot of diagrams, and she has talked you through the whole of linked lists, which I'm a bit devastated about, because I love linked lists and I love drawing linked lists. So you've done traversing, you've done inserting, you've done deleting, and now you're doing... Okay, I haven't missed the Thank you. And now you're doing the assignment, so now I guess you're doing even more linked list stuff in a different context. So that's a bit exciting for you. Today we're going to talk about the exam, what it is, what is in it, what's the format, any hits, and just one tip, not many, obviously, just one tip there. And I'm also going to go through some questions that are going to be in the exam. Next week, for your absolute, happiness, no new information at all. It is all about revision, and I'll get you to vote on what kinds of questions you want to cover next week, and I will do many of them in the lecture, and I'm making them in a similar format to the exam so that you get some practice as well. Okay, live lecture code. Oh, my experience. My experience is this survey that the university does. You get to rate the course that you have done, and you get to give us some feedback, and then we use that feedback to improve the course. So please fill it out. It really helps us to improve the course as we go on. Please be constructive with your feedback. I don't really love the comments about what I wear. That's not really relevant to how I can improve the course. So keep it constructive to things that we can actually act on to make the course better. Okay, so it's not improving your course, that is true, but I have taken your feedback across the last sort of 10 weeks to try and improve things, but it is improving the course for those that come after you, which is always a really nice thing to do. Okay, so what is the exam? What is in it? Absolutely to no surprise to you, it's everything that you've learned so far. So if statements, while loops, all your variables that you've done, so your ints, your doubles, your chars, your structs, strings, arrays, pointers, and linked lists. Literally everything that we have covered. I suppose that comes as no real surprise. Okay, what are the dates of the exam? And a few of you have asked this before. Your exam is not over 2 days. My goodness, no. We are not going to torture you that much. What it's saying is there are too many of you to fit into one exam, so you are spread over 3 sessions. And those 3 sessions are occurring on the 30th of April or the 1st of May. There's going to be 2 sessions on the 30th, which is a morning and an afternoon session, and 1 session, a morning session, on the 1st of May. For those of you that have a clash with another exam, you would be automatically put into the session that does not have a clash. For those of you that have a maths exam, the maths exam also has many sessions which they do not put on the timetable, and so you are able to also choose a session that doesn't clash with our exam. So, 3 sessions, and for those of you in the afternoon session, you also get the pleasure of being corralled in a room for 20 to 30 minutes. So you will have to show up early, and you're going to be led into a room, and you're going to have to sit there whilst the morning session finishes their exam and is let out of the session. And the reason for that is so that you cannot get any information about the exam. For those of you sitting the exam on the 1st of May, you're going to be sitting a completely different exam. So that's not going to affect you at all. We're not going to coral you overnight. That would just be a bit weird. So you will be given a seating location somewhere in the CSE labs, and that will happen closer to the date of the exam. It will mean that you know where to go. For those of you in the afternoon session, you will be told where you are being coralled, because you will be coralled in multiple rooms, and you will have to show up there. So the morning session is 10:15 to 1:30. You'll notice that there is a little bit tucked on there. So the exam is going to be 3 hours long with 10 minutes reading time, and then 5 minutes because it's usually a bit chaotic to start with. The coralling occurs from 1:20, so 10 minutes before the exam ends, until 1:55. So the coralling doors close at 1:30, which means that if you get there afterwards, too bad, you're not allowed in, which means you cannot sit the exam in the session that you are in. So please, please, please arrive in time for the exam. And then the afternoon people will go from 1:55 till 5:10. So again, excitement galore. There is a lab next week, obviously, your usual lab, but that will give you a practice exam. What it will also do is that practice exam will be in our actual exam environment. Okay, that means that the practice paper will be similar to the one you'll be sitting. The environment will be exactly the same. You will get to practice how to use the environment, and we will make sure that you're able to submit the exam with no problem, submit your questions. It's going to be a similar command as you use give every week, except it's going to be submit. Auto tests are run exactly the same way as they are for your labs. And you can, again, submit as many times as you want. We will only take your last submission as the one to be marked. When you're doing the exam, please, 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 please make sure that you actually submit something, because we can find your auto tests, but it makes it a lot longer and a lot harder to actually mark your questions. And when your marks are released, you will see that you have failed probably because we didn't actually see your questions. We do go through and try and find something for those that are empty, but sometimes we miss some. So please make sure that you actually submit your questions. Okay, so the exam has some hurdles. If you remember from the course outline and from the first lecture. So we've been playing around with the format of the exam. So right now the hurdles will come at the front of the exam. So the first 4 questions are going to be your hurdle questions. You pass either question 2 or 4, which are the array hurdles. I know it doesn't make sense, but we decided that since you've done linked list first, linked list last, linked list is fresh in your minds, that is why it's going to be question 1, so you can breeze through it. And then arrays at 2 or 4. So you have to earn a mark of 50% or more in at least one of those array hurdles to have passed that hurdle. You don't have to get the full marks, you just have to pass it, please. And then there's a linked list hurdle. Similarly, question 1 or 3, they are clearly marked, and you must also earn a 50% or more in that question. Means you have to pass half of the auto marking that are for that question. If you've passed all the auto tests for one of these questions, chances are you've most probably passed the actual hurdle. So the questions are clearly marked as exam hurdles, and you have to do them. Please attempt them. Please, they're not, yeah, you've got this, you've got this. What happens if you don't pass them? You fail the course, right? You fail the course with a grade of UF, it's called, which means unsatisfactory. So whatever mark you get, doesn't matter, you will fail the course. Yeah?
Are there hidden test cases?
Are there hidden tests? I will cover that in a second, in a few more slides. So, yeah.
Will they check for not for style?
They are not checked for style, but if you have failed one of those hurdles, anyone who doesn't score full marks on the testing and stuff, I look at every single hurdle manually to make sure to give you as many marks as possible so that those of you who can pass the course. Sometimes it's going to be the simplest thing and you actually should be getting close to full marks. So if you have written your code in a way that I cannot read it, I cannot give you marks, right? So that is the reason. You don't have to have perfect style, but give me some white space, or it's very difficult to read. Okay. The exam. It is closed book exam, but you have a safety blanket, and that safety blanket is the course website. It will remain open, which means that you will be able to see any lecture material or code, any tutorial material or code, and any lab material or code. You will not be able to see any of your own code. Also, please use this as a blanket as opposed to as a crutch. You will not have time to start researching every possible question or lecture note in the exam. The exam is only 3 hours long. You will run out of time. So you really need to know what's going on, but it is there, show you need to look at something. Exam conditions still apply. Do not communicate with anyone about the exam within 24 hours of the exam start time, as that is considered plagiarism. The forum will be locked down and you will not be able to post anything on it for 24 hours. We do also look at Discord and all the rest of that, so please do not discuss the exam for 24 hours after you have completed it, as some people might still be in the process of getting to do their exam. Yeah.
When you say we have access to the course website, does that also mean that we have access to the COMP1511?
Yes, you do. Yes, you do. Okay, and you can't obviously share your code with anyone. Again, that should come as no surprise to you. That has been the policy the whole time, the whole term, really. Okay, so no communication. If you experience any issues during the exam, if you think that there is something wrong, if there is a typo, if something is not working, if your Tiger VNC has decided that it's not having a good time and it's very, very, very slow, please don't just sit there and think this, freak out. Just raise your hand. We have things that we can do and we are there to help you. There is invigilators in every room and I sit outside as well, so we can find you help straight away. So please don't just suffer in silence. Please actually let us know if something is going on. Okay, when you come into the room, I really don't want to do this actually. Maybe I should. Okay, no, I will. Okay, so when you come into the room, you'll, take your seat. You're going to have instructions on how you start the exam. The papers are personalized as well, so that means the paper that you have might not be the same as the paper to the person next to you. Who knows? And different sessions also have slightly different exams. So please, again, don't discuss anything. You'll fetch your exam. You'll be told what the command is to fetch the exam, and what that will do is it'll just fetch all the starter code that you might need with the exam. So you'll have the files that you can work with and start with. All the instructions are provided for you. You're not left to guess anything. That's not part of this whole thing. So don't stress. The university has a fit to sit policy. This is really, really important. If you show up on the day of the exam, you are declaring yourself fit enough to sit the exam, which means it's going to be a hell of a lot harder to get special consideration if you're not well. If you wake up that morning, okay, if you've done any vomiting, please don't show up. If you're feeling unwell, please don't show up. If you've got COVID, please don't show up. COVID has happened twice now to all the invigilators and all of us because people show up anyway. If you are sick, you will get a supplementary exam, okay? Please just apply for special consideration and stay at home if you're unwell. I don't really want your lurgy. But once you show up, it's much harder to, then be like, well, actually, I'm not well, so I need special cons. However, I don't really want you fainting in the exam, which has also happened before, and an ambulance takes a really long time to get to the campus, so please don't. But if during that exam, and it's not an online exam, I don't know why that says online, you are feeling unwell, okay? You cannot continue the exam. It might happen. You just raise your hand, okay? Stop working on the exam, raise your hand, let the invigilator know. You will be walked out, usually to me. And what I will do is I will find out what you are feeling and then probably try and get you an appointment straight away at the health services on campus, which means that you're able to get a medical certificate and also be attended to straight away. And that means that you can then go and apply for special consideration. I would prefer if you all felt okay during the exam though and just breeze through it. That would really be much better. Please do. Now, if you do get a special consideration and you are under that fit to sit policy or whatever it is, you will be granted a supplementary exam. Okay, usually if you're medically unwell, you get a supplementary exam. The supplementary exam is held in May, and I've looked it up. It says sometime in the week 20th to 24th of May. We do not yet know the date. We get given the date, so we have no idea yet. It's a centrally allocated date. But if you think you will need that exam and you will be sitting the supplementary exam, you need to be available for that date in May sometime. Because if you don't sit the supplementary exam, then depending what the issue is, you know, we kind of go again or we don't go anything. So, okay, Tammy will put up, we're going to be running some revision classes in week 11. And Tammy will put up a post with how to register for them and all the details of those. So if you feel like you've fallen behind or if you feel like in any way that might be helpful, please register for them and please come along. Okay, so someone's saying, oh, I can't do 3 dots. Don't worry, you can still do really well in the exam if you can't do 3 dots. Let me talk you through the format of the exam. So there is 11 practical questions in this exam and the distribution of marks is as follows. How fun is that? None of them are equal. So make sure you realize that none of them are equal. Questions 1 to question 4 is going to be your hurdles. They are 12 marks each and they are programming questions, okay? Questions 1 and 2 are 1-dot questions. Questions 3 and 4 are 2-dot questions and we're going to talk about what that means. Then you've got questions 5 to questions 8. Those are 5 marks each. And they are like a debugging question. You'll get given a piece of code. That code doesn't work. You need to do something about that code to make it output what we want you to output. So it basically requires you to understand what on earth is going on. Okay, question 9 and 10, they're 11 marks each. And they are programming questions. And we'll talk about what they cover in a second. And then question 11, the final hurrah, is a 10-mark question. I don't know, in the same term last year, I think 20 people out of the whole course did question 11. So don't stress if you have not gotten up to it, if you have no idea what that question is even asking you to do, don't worry about it. We'll talk more about it in a second. The questions are similar in style to the questions that you've been doing as part of your problem sets and as part of your revision exercises. So you should be familiar with the way they're set out, the assumptions that you are given, and so on and so forth. And they're also rated in the same way as your labs are. So you get to know which questions you will be able to do. So if throughout this term you have not been able to do 3-dot questions, don't despair when you can't do them in the exam as well. You can still do very well without doing them, just the same way that you can do well without doing them in the problem sets as well. So I hope that you can attempt and complete the first 8 questions, which is the 4 hurdles and then the debugging questions afterwards. And that's enough to do quite well. Okay, I don't know, clearly I don't like to go in order, so I've decided to look at questions 5 to 8 first. So those are your 5 markers. And they used to be the first questions in the exam, but what was happening is that people would get stuck on them for ages and forget about the existence of the hurdle questions. So that's why they've now been moved into the middle of the exam. So questions 5 to 8 are your debugging questions. They're going to basically ask you to debug some code, and you'll see some examples next week in the practice exam. Okay, now our programming questions, the practical questions. They're Again, rated in difficulty from basic to very difficult. Same difficulty rating as the problem sets. Some will have some starter code, which you've been having as part of your labs and as part of your assignments. So you will fetch that starter code and then you will work with that. You'll need to compile and test each question. You will have access to auto tests, but they are just tests. At the beginning of the exam, there are not many hidden tests, but as the exam goes on, but there are still hidden tests even in the first question and in the second question and in the third and fourth. Towards the end of the exam, the auto test reduces and there is more hidden auto tests, the same way as you've experienced in the assignments. So you still have to do your own testing. Okay, everyone keeps wanting to know, but what happens about style? So exactly what I said, you don't have to have perfect style, but I have to be able to read it and the other markers have to be able to read it because otherwise they can't give you marks. If you have 7 nests, I will not be able to know what's going on quickly and there are many places to mark, so you're going to lose a bit of marks there. What else? Yeah, okay. Okay, so when you fetch your exam in the beginning, it will bring all of your starter files as well, so you'll have everything ready for you. You don't need header comments. Someone's asked that. Absolutely, you don't need that. Don't worry about that. Don't waste time on that. And there are part marks for every question, okay? Question 11, we'll look at them manually. We'll see if there's part marks given for that. Question 10, again, manual. So most of the questions will also be manually looked at to see if any marks can be given. So you can attempt them. Read all the questions before you start. I know it seems like an obvious hint, but you'd be surprised how many people do the wrong question, kind of the question that they want to do instead of the question that is being asked of them. Start with the easier questions. In fact, just start with the hurdles. Do the hurdles and then you can, do whatever you want for the rest of the exam. Hopefully just keep doing questions to get more marks. Before you start answering, draw some diagrams, do some thinking, clarify what you're going to do. Actually think about what you're going to answer. Often towards the later questions, in question 10 and question 11, I get quite a bit of essays of people writing comments of how they would solve the question, which is actually quite nice. And sometimes if their answer is very nice, I will give it some marks, because if someone has thought through what to do but just hasn't had time to write the code, but their thinking is correct, that's quite nice too. But if their thinking is wrong, I will not give you marks. Sometimes people write lyrics to songs. Great. If you've had time to do that, I hope you finish the whole exam. But really up to you how you use your time, as long as you do the hurdles. Please just do the hurdles. So debug, test all your questions. Please do lots and lots of things. And the last point, less questions answered well or completely is better than more questions partially answered. So do the hurdles, try and get full marks for the hurdles, then do the debugs, then go on to do all the rest of them, okay? And try and kind of do as many completely as possible. Okay, so the exam is not usually considered easy, and I just want you to kind of get that expectation out of the way, but it's not an impossible exam, and it's not a surprising exam when you go in there, right? I don't like surprises. I don't think any of you do. When I was a student, I hated when you went into the exam and you would get asked questions that absolutely you have not learned anything of that, so it just makes no sense. The questions will be similar to what you have seen in your problem sets. They will be similar to your practice exam. They will be things that you've done. The latter questions will be much harder, okay? But you don't need to do them to do well in the exam and to do well in the course. So just breathe and make sure to kind of just go in, read it, and attempt it. So questions 1 and 2, they are one-dot problems. They're similar to the same questions you'll see on your practice exam. Question 1 will be a linked list hurdle. Question 2 is an array hurdle. And they will test your ability to create very simple C programs. I'll show you what one of these questions looks like, the code from it, because you will get given some code in it that we use for testing, and some of it, so I'll show you exactly what it looks like, right? So it's no surprises there. Basically, you might be using scanf. Usually you're not going to be using printf. We do the printing out for you, which means that you're not going to fail auto tests for not having, you know, a simple space there, or you're not printing something out the way we want it. So you don't have to worry about that. Use your if statements and while loops, and then you'll have arrays in question 2 and linked lists in question 1. So the linked list stuff in question 1 is going to be simple traversal, something simple manipulation in it. It's not going to involve inserting or removing nodes in a question 1. However, there you go, there's an example, and that's an example that I will do with you after the break. You're going to get obviously the question you will see is going to have a lot more context around it, just like your labs. But basically, given a linked list, print the largest value in that list. And that's going to be like a question 1. Or given 2 linked lists, return the difference in the number of items in the 2 lists. Again, we're going to look through them. Question 2, you might get given an array of structs, and you have to loop through it and find something and manipulate something in there. One potential, or you might be given an array and you have to count the number of something in it, or you might have to do something else with it. Find something in that array. Okay, the 3 and 4, they are 2-dot problems, okay? So they are going to be similar to your practical exam. You'll see what they look like. Question 3 is going to be a linked list hurdle. Question 4 is an array hurdle. You don't have to pass both of the linked list hurdles, just one of them will suffice. And same with arrays. If you have already answered and passed question 1 and 2, it means you have passed the hurdles already. So this is now just marks. You're getting as many marks as possible in this exam. They're harder applications of the hurdles. So everything you know from 1 and 2, plus you might be looping through more than once. Maybe for a linked list, you will be doing insertion or removal of nodes, and you might have to test more difficult conditions, and you'll keep track of more than one thing. Okay, 9 and 10, they are 3-dot questions, and they are starting to get harder. You'll feel it. You'll really feel it in the exam. They are harder manipulations of arrays, potentially string manipulation, and a harder manipulation of a linked list for a question 10 usually, which means you might add, remove items or do other things, check other things. The context is going to become weird. Potentially you might use malloc or free, structs, pointers, enums. Nothing's off the table on question 10. It's just so much fun. So more complex combinations and some interesting problem solving as well. So this is where we kind of get into the problem solving aspect. Now, just as you thought things are getting interesting, you get to practical question 11. This is a combination of a 3-dot and the skull problems. So what I was saying before, you know, you don't necessarily have to do it. Most people don't even get to the question. But if you are aiming for a HD, it's highly likely that you will attempt this question. Everything that we have taught in this course might be in this question, plus some very complex problem solving. So it's really going to test your ability to break down a problem, to read a spec and understand what it's saying. In your prac exam, there's going to be an example of a question 11, so you can kind of see the difficulty level. And what I was saying before, if you just do it partially, you'll be able to get some marks as well, depending what's going on. Okay. How's everyone feeling? Yeah? Looking forward to the exam? Okay, what should you study? I don't know, everything I suppose. But you should really go through all the problem sets again. Okay, and we release revisions as well, revision questions. Go over the revision questions as well. Do as many practice questions as you can, because it will help you to kind of read questions and understand what they're asking. So it's really important to do as many questions as possible before you go into the exam so that you feel comfortable doing coding in the exam. The basics are important as well. Okay, most of the marking is automated, but Again, your hurdles will be marked manually as well for those that have not been able to complete the question for full marks. And that is to make sure that those that should be passing are passing. And we also mark other questions manually as well. And marks are given for correct code, not for passing auto tests. Okay, so if you've maybe missed an auto test but your code is really almost there, you will get most of the marks. So while some of the exam is going to be quite challenging, you don't need to complete it to be successful in getting a great mark. I know that exams are really intense. I always found exams to be really hard. I find silence really hard. So I struggle in big rooms where people, even worse in a computing exam, everyone's going to be typing and you're going to hear the keyboard going. Try and tune it out as much as possible. You don't know what they're typing. They could be typing a beautiful, lyrics to a song for me to read. You just don't know that. Actually, I'll just embarrass Sophia. In Sophia's exam, who's the admin, in her question 11, she basically wrote a love letter to the subject, 1511. Clearly, that's how you get to be a tutor. No, but it was a great read. And so she was very busy typing, but it had nothing to do with the exam whatsoever. So it might have made people feel awful, but you don't know what people are typing around you. They could just be trying to solve the question. Each one of you is also going to get a piece of paper in the exam, like a scratch paper. You can ask for more paper if you want. You can draw on the paper, you can diagram on the paper, so you can use it to kind of decide what your solutions are. Make sure to breathe, make sure to sleep before the exam as well, and to eat well. Please just go in feeling confident as well. And draw diagrams. Please go over the problems that we have given you. So for all of those problem sets and the revision questions, for all that practice, and then the details are coming also for the revisions. Okay, it's a good time to take a break. I would love to know how everyone is feeling. Why don't we do a little poll? Actually, and then for those in the room, how are you feeling about the exam? Thumbs up, thumbs down. Yes, a few thumbs up, a few middle ground. Yay! I promise you, I swear, I feel like it's one of the better exams that you might do in this, in your degree. There we go. I hope that you don't hate me after the 30th and the 1st of May. Okay, let's have a 5-minute break and then we'll come back and then we will look over some of those questions and what your starter code will look like so you get familiar with what all of that is. Okay.
So I'm really confused about linked lists
Oh.
and like how pointers fit into it. Like I don't understand.
Okay.
Like the struct node thing, right? Why is it a pointer? Like struct node pointer. What is that?
Okay, so the reason it's a pointer is because each node, so a linked list is a structure that doesn't, we take the memory as we need it. So each time we want a node, we malloc some memory. And what malloc returns to us is a pointer to that piece of memory that it malloc. Okay, so that means each one of these nodes is going to be all over the memory. It's not contiguous, it's not one after another like an array. It can be spread out. So we just take it as we need it. That means that this thing in here, this next pointer, tells us where the next node is, because otherwise we wouldn't have any clue where it is. So it's like a bit of a scavenger hunt. You have to go one location, then only at the next location you'll find out where the next thing is.
It is head, right? Like that's the
So
point.
the head is, it's not a malloc piece of memory. What it is, it's just a pointer in that it holds the address of the first node. So it's not a node itself.
Okay, it's not a node.
It's not a node, it's a variable, but it's a pointer because it needs to hold an address. And it holds the address of the very first node, because otherwise you wouldn't know where on earth to start your linked list.
And that makes it easy to like switch it around because it's not actually a node.
It's just a pointer to wherever the first one is. But if you change it, you need to do a whole bunch of things in between as well, depending on the question is asked.
And when they use like stuff like struct node asterisk and then make a function, like what does that mean?
It means that the return is going to be a pointer of type struct node. Usually in a question where you might change the head, that's when you have to return a struct node star, because you might return the pointer to a node, and that node is going to be the new head.
So it's a type of variable.
So it's a pointer to a struct node. So it's a pointer, it holds the address of a struct node. That's really all that it is.
And we've defined struct node at the top.
Yeah, that's right.
Do you have any advice for linked lists in general?
I think it's all about diagrams, but I also think, I've seen the emails from you. I remember that you're the person traveling. I think what we should do is get you into an extra tutorial this week, so that someone can sit down and go over it properly with the questions. To give you some, so I will find your email and reply to you.
Sorry about the
And I-
trouble.
No, but just, I think it would be really beneficial. Otherwise it's a lot to catch up on.
Assignment.
You really, and they can sit down and go through a bit of the assignment with you.
I really appreciate it. Thank you so much.
I'll find you tonight in the evening.
Thank you so much.
No worries.
I appreciate
Watch
it.
out the chat.
I was just wondering, in terms of academic integrity, are we allowed to work with others on the SCAL questions? Yes, just to get
So you can work together on the code,
Yeah.
discuss the song,
Okay, yeah.
and then you have to do your own assessment. And which one do you want feedback on?
Well, like with him going back through things like that.
Okay, switch me on.
Okay. No worries.
All right. let's get started again. Someone is feeling really confident in the chat. What if we finish the exam early? Whoa, feeling good. It has happened. We have had a few people finish early. If you're in the morning exam, tough cookies, you just have to sit there till the end of the exam. You cannot leave early in the morning exam. But if you're in the afternoon exam, you can raise your hand and you can leave early. We just record the time that you've left and that's it. On the 1st, if you're in the morning session, you can leave as well. So really on the 30th of April is the only time you cannot leave early from the morning session. You have to stay the whole time. Does anyone ever get 100% on the exam? Why do you need to know that? You shouldn't compare yourself to anyone. It is what it is. I have seen 100%, not often, but they do happen. Usually 1 or 2 people a term, which is, neither here nor there. Like there is over 1,000 students in this course. That's a very small percentage of people that can get 100. So, please don't stress. You will get an email that will allow you to elect which session you're going to be part of. Unless you have a clash, then you've been assigned to a session. And if there are any other issues, a particular reason why you cannot be in a particular session, please let us know and we will make sure that you're not in that session. Someone wants to use ChatGPT? Absolutely not. And if you're using that, I don't really want you ever coding anything that impacts my life in the nicest possible way. Okay, so DCC help is not available in the exam. I should have said that, but DCC obviously is available in the exam. Yeah, okay. What's the average? I don't believe in averages and I don't believe in comparisons. You do the best that you can do. Don't worry about how everyone else is doing around you. Everyone's got very different ways they learn and very different also levels of what they think is a good mark. Just do the best that you can. A lot of times, for those of you that are worried about failing, a lot of times the failures happen when students don't attempt most of the course, and that obviously leads to failure because it's a little bit hard to catch up in week 9 on what happened in the first 9 weeks. So just try and kind of work through consistently and do your best. Question 11s are absolute, they're art forms. You have no idea how long it takes to come up with each question 11. Let's not talk about it, but they're beautiful questions. Okay, so let's have a look at what it looks like when you get a little... Who makes the exam? Who do you think? ChatGPT? No. It's definitely not ChatGPT. I make the exam with help from a few tutors as well, and it's really, you get some very nice questions. Well, obviously you're not going to think that when you're sitting the exam, but I think that. Okay, we don't reuse exams for those of you that think that's going to help. Each term the exam is different. There are no maths heavy questions. We don't expect you to know maths to do computing, although, could be helpful. But no, there is no maths heavy ones. You'll get a practice exam. It's probably going to be the same one that was in 2023. Okay, let's have a look at what the question looks like. So let's first of all go to... Don't know why that was a weird sound. Okay, so this is what you get given, okay? When you look at the code. You will get given something like this. It's going to have a lot of code in it. But what it actually has in it is going to be a definition of a struct node, which is fantastic. You would know that. Then the function that you have to write, and you will only have to write that function. You don't have to do any of the surrounding rubbish. We do that surrounding rubbish for you. So what we do for you usually is we have a main function which will print something out, which means you don't have to do the printing, and that means you're not going to fail auto tests for not having a space or not having something else that's causing a failure that is absolutely nothing in particular. What we also do is we have a function here that will convert whatever numbers you put on the command line into a linked list, which means that you are able to test your code. And we do this for you. You don't have to do anything about it. You do not change this function. This function here is the function that converts whatever happens on the command line to a linked list, which means that all you need to do is do the function that we ask you to do. And that function is going to be called in the main, and that's all you need to worry about. So let's do this question, and then I'll show you how to run it so that you can see that you don't need to really understand what we've done to convert the list, but you don't even need to look below it if you don't want to. If it's freaking you out, don't look below. But all it's doing is just taking something off the command line and making it a linked list so that you can manipulate it in your function. Okay. Gab said I would be surprised if you get a copy of an actual exam. So, a year ago, we by accident released the actual exam instead of the prac exam. And then we had to write a whole new exam. So that is absolutely not happening this term. That's been awful. That was awful. Yep. Redact. Yeah, that wasn't my term, so it wasn't my problem. But I felt their pain. Okay, so let's write this code. Okay, I don't know how much you've done of the linked lists. I assume everyone is loving linked lists. But often in the return, there's going to be a number. Please don't forget to change that number to whatever the return should be. Otherwise, I'll see you failing an auto test because all of yours returns 42, and I'll know that either you haven't written anything there or you forgot to change the return. Okay, so couldn't you have used the practice exam as a real exam? No, because the practice exam has been used before as well, so it is available. Okay, there we go. Do you ever have to make a program from scratch? You might have to in the first questions, but often there's going to be some code around and a main around it to help you as well. Yeah. You don't need to put your name or ZID because when you submit, it's going to go into a folder with your name on it. Your ZID, so we'll know where it came from. Okay, so let's do this largest business here. So this question basically wants you to traverse a linked list. So you want to traverse a linked list and find the largest number in it. Okay. Okay, so I haven't seen you doing linked lists. What do you think we should do first? If you were in the exam, yeah. Beautiful. And surely you're going to you've all done this every single time. You make a current pointer and you point it to the head of the list. Okay, so then that's going to keep track of where you are in the list as you traverse the list. Okay, so now we know where the current is. So let's say, for example, the list is 3, 4, 5, 6. Our current right now is going to be equal to 3 because it's going to be pointing to the head of the list. Okay, so this would be a question 1, okay? You're meant to really be able to do this one quickly and move on with your life and also get a little confidence boost, I hope. Okay, what else do we need if we want to get the largest number in the list? What else should we have to keep track of things? Yep, okay, we want to have something so let's have int max, and what should I make it equal to? Okay, let's make it equal to 0. What happens? Yeah, who said? Yeah, so what happens if I've got negative numbers? And what happens if the list is made up all of negative numbers? Yeah, if you make it equal to 0, you're going to miss out on that case. So, yeah. Yeah. Yeah, okay, good. So I can make it equal to head data or current data, whatever. I will hit potentially one case that is likely to be a hidden test off an empty list, which means that when I try to do this head data business, I'm going to access a null pointer and we're going to have a big old crash. So we'll deal with that in a second. Let's just do it for a list that has some numbers and then we will look at what happens when it crashes. Okay, so now we've got our first thing, so that means we've got a current is pointing at 3 and our max is also pointing at 3 because it's pointing to whatever's sitting at the head inside the data component. Excellent. Now we need to traverse the linked list. Yeah.
So then you do while head next is pointing to null equals n. Oh, sorry, while current is not equal to current next is pointing to null, current is current next.
Okay, so in here I'm going to whilst current next is not equal to null. Can you tell me why I'm not going while current is not equal to null? Why will I do current next is not equal to null?
Well, you could actually do current is not equal to null, but it depends on which order you put the current equals current next and comparing the value of max.
Okay, all right, so let's go with current next, then we'll change it to the other way to see what it does, okay? So good, so we've got whilst current next is not equal to null, and at some point I'm just going to put that here, we're going to move our current pointer along, and here we're going to check whether or not it's equal to the max or not. So I'm going to check if my current data is going to be greater than the max, and if it is, then I'm going to set my max to whatever is sitting inside current data. And then I'm going to move the list along. And what should I return over here? Not head. Max, yep, good. I'm returning an int, and I'm returning the max one. Okay, so we think this is going to, well, it's going to fail obviously in one case that we've discussed, which we'll talk about in a second. But let's see what it does for a normal case. Okay, so let's compile it. So largest.c. Okay, so everything compiled. So now what this question allows you to do and what our functions allow you to do is that they allow you to do, like run the code, so run the executable, and also put in a list. And I'm going to put in the same, so 3, 4, 5, 6. So what it's going to, we are the ones that are taking this off the command line and making it into a linked list, but it allows you to test what's going on. Okay, so what's happened here is I've run this list with 3, 4, 5, 6, and what it's done is told me that the largest is 5. Why is it getting it wrong? Yeah, you're the perfect person to answer it.
The order is incorrect. You should be making current next.
Yeah, so either I have to change my conditions in here or I have to go whilst current is not equal to null. And what that will allow me to do is it will only stop outside of this while loop. When I exit this while loop, current is going to be equal to null over here, which means that I've gone past the end of the linked list, and that means I've visited every single node in my linked list. Okay, so let's run it again. Let's compile it. And let's run it. And now it's going to give me the right answer. What would you test? What would you test to see whether or not you are failing this, well, whether you will get something wrong? Yeah. Negative numbers. Let's do that. Okay. Okay, let's run that. Okay, working for negatives. Okay, we've talked about the case where it will fail, and it will fail miserably if we have an empty list, because what's going to happen is that it's going to, over here, access and dereference a little null pointer. Okay, so how can I make sure that that doesn't happen when I'm really doing my coding?
Is current equal to null and return null?
Yeah, so, oh no. Now I can't see the online people. And the university wants you to have a 14-character password, so we could be here forever. Okay, so in here, I would check that that's not equal to null. So here, I don't care if, head is equal to null, it's equal to null. I could just check if current is not equal to null, then I'm going to make this, and it doesn't matter, it could be head or it could be current. Then I'm going to set the max as the current data. Otherwise, I don't know, what should I do otherwise?
Return null.
Oh, spelling, excellent. What should I return if the list is empty? Usually the question will tell you what to return if the list is empty, okay? Let's just go with 0. Let's pretend that this question, that was the assumption in it. Okay, let's run it again and see what happens if we give an empty list. What did I do? Yeah, I know. Yeah, go on. Someone tell me what I did. Hey? No, I did, but it's, yeah, the scope of my variable is off because I declared it. Okay, let's have a look. What happens now? And let's run it with nothing, and it's just going to return 0. Yeah.
Instead of checking if it's not null, if you check if it's null, and then if it's not null, if it's null, it will return 0 immediately, and then under that if code, you can start declaring marks and run the rest of this.
Yeah, absolutely. I can absolutely do that, which is an efficient way to do it. Okay, now, thumbs up, who wants to do it line by line, or hands up if you want me to run through this code line by line. No? Everyone's good? Oh, pardon? There was one hand? Oh, I'm sorry that you were so lonely in the audience. Anyone else? What about online? Who wants to do it line by line? It's a very, very slow week 9. Everyone's dying a little bit inside. 1 yes online. Wow, 1 yes in here, 1 yes online. I'll do it quickly and then we will move on. 2 yeses online. Thank you. That's okay. No thanks and a hello. Sure, why not? Okay, it's a real mixed bag here. It's a real mixed bag, which puts me in a really weird place, where I now have to run through it quickly, but not too quickly, but then too quickly because people don't really want to run through it. Let's have a look. How do you feel? I haven't set up my drawing very well. Oh, I think I just broke something. Well, should have prepared this earlier. Okay, sorry to those that are going to be bored for the next 5 minutes, but let's just quickly do it. Oh, for goodness sake. I hate the sign-on stuff. I hate it. I hate it. I hate it. I hate it. I've got 4 questions for us to do today. Okay, great. Whiteboard has authenticated me. It's exciting stuff. Okay, so let's do it. So we've got our largest. Okay, so the first thing, and let's pretend that the list I'm entering is 3, 4, 5, 6. So what I'm going to have is the numbers 3, 4, 5, and 6. Where am I? Oh. I could be anywhere at this point in time. I don't know where I am. Oh my God. I don't know where that whiteboard is. I'm going to do it like this. Okay, 3, 4, 5, 6. Struct node current is equal to head, which means that my current is now equal to 3. I've got a max, and here I said if current is not equal to null, which it's not, and that means that I go into this if statement, and my max is now going to be equal to whatever is sitting inside current data, which is going to be my 3. Okay, great. So now I'm going to go in here, and my current is currently 3, and it's not equals to null, so I'm going to go inside here, and I'm going to check. Is the current data greater than max? Well, 3 is not greater than 3, so I'm going to move on and just go to current is equal to current next, which means that my current is now going to go to the next thing in the list, which is number 4. I'm going to check, is 4 equals to null? No, it's not. And I'm going to say is whatever inside current data, so is 4 greater than max, and max is 3. So it is, which means that max over here is now going to become 4, because max is going to be assigned whatever's sitting inside current data. Then I'm going to move my current along by 1. So that means I'm now at 4, and I'm going to move it on to 5, which is the next one over. And I'm going to check, is 5 equal to null? No, it's not. Is whatever sitting inside current data, so is 5 greater than max, and max is 4? Yes, it is. So I'm going to go into this if statement and change my max to 5. And then I'm going to move my current pointer along by 1. So it's going to go from 5 to 6. So that means the current is going to move on to 6. And I'm going to check, is current equals to null? No, it's not, which means I'm going to go in here. And I'm going to check, is current data, so is my 6 greater than max? Yes, it is, which means I'm going to change my max again to be 6. I'm going to shift my current to my current next, which means that it's going to go to the end of the list, and that means it's now equal to null, because it's at the end of the list. And when I go into this while loop, current is going to be equal to null, which means I do not enter this loop. I've broken out of it, and that means all I do here is return max, which is 6, and then it goes through to largest, and then voila, you've got your largest, you've got the lovely largest thing going on, and that's, you know, all sorts of exciting for you. Okay, so that's that question. Let's have a look at the next question now. Should we do one more linked list, or should we jump over to an array one so you can see what the array one looks like? Jump to array? Let's jump to the array. Okay, so the array one, let's do the struct one first. Okay, and it was direction. So for the array question, you're going to get something that looks like this, potentially. So what you'll get if it's a struct, for example, and that not necessarily if you don't have a struct, the next one I have as an example doesn't have a struct, so it allows you to see what it looks like without a struct. So this one has a struct, and then what it will have is it will have the function that you want to be modifying, okay? And this is the only function, again, that you need to change. But what you're going to get as well is you're going to get a simple main function that will allow you to test what is going on and whether you've actually written the right function, okay? You do not need to change anything in your main, but when you're testing your question, what you should be changing is the values in here, because it will allow you to see whether or not your function is working, whether it's doing everything correctly. Okay. So anything you change inside main will not be marked, only your actual function will be marked. So we don't do anything weird in the main, but you know, just kind of work with it. Someone's saying it's weird syntax. It's not. It's just kind of declaring it all as one, as opposed to assigning it in 70 goes. And again, your main will do the printf statement for you, so you don't need to do anything about it. So in this question, let's say I want to count the total number of left steps, so anything with an L, I want to count up the total of them, and then done. And again, remember to change the return so that it's not sitting at 42 or whatever other number is there. Usually it's just 42, because obviously meaning of life. Okay, so I don't know why. I'm superbly jet lagged. I'm sorry. Okay, so what will I do when I've started this question? Who remembers arrays? No one, right? Yeah, everyone's moved on. They're on the crepe stand. They don't care about the flowers anymore. Okay, go on. Yep.
So you want to iterate through the entire array and you want to check its elements has the corresponding
Yep.
check if they contain L characters.
Perfect. Okay, so we want to be able to traverse the array. Was that a clap? Yes. Well done. Yes. That was so good. Second time. Yes. Deserves a clap. I agree, especially on a Wednesday afternoon. Okay, so we want to be able to traverse the array. It's clearly becoming a bit of a thing. You know, linked list, you got to traverse the linked list. Array, you got to work through the array to see what's going on. Okay, so we're going to move through the array and we're going to count something. So I'm going to have a counter that I'm going to set to 0, and that's going to count the number of stuff that is occurring. And then I'm going to move through the array. So I might have a for loop for int I is equal to 0. I is less than, what's less than? I guess we're given the size. So I is less than size, I plus plus. And I'm going to check if, now who remembers how to access not a pointer struct, but just a normal struct? Dot, thank you very much. Okay, array at index I dot direction. So if that is equal to L, then I'm going to add to my count whatever was in the count, plus I'm going to add array at index I dot number, which was the number of steps. And I've actually got the wrong, this is dir. Okay, great. Anything else that I need to do in this function? Yeah, return. What should I return? Yeah. Okay, we happy with that?
There's a question online. Are these two examples hurdle?
Yeah. Hurdle questions, example hurdle questions that are, yeah, 1 dot. So an example of question 1 and question 2, basically. Okay, so let's compile it. Oh, okay. That's because okay, so it's compiling, and then let's run it, and it's giving us 10. So if we look over here, anything with an L352, that gives us 10, so fantastic. If you wanted to check whether or not it's working, you can change any of these letters if you wanted to, and then run it again. And that's allowing you to actually do your own testing and do your own checking. So if you run it now, it's going to give you a different number because only 2 of them are L. So you can modify the values in the test array that we give you, and that will allow you to test your function. Okay, should we have a look at a different one that could be a question 2? Okay, so a different one that is a question 2 might not have a struct and might instead, I know, exciting. But similarly, it's got a function that you need to modify, and then it's got a test array that you can use to test your own function inside the main, and it will also have the printf statement that you will use to, you don't need to change it, so you'll be fine. But this is kind of the place where you would change something if you needed to change it. You can change any number in the array to then test it out. So in this 1 dot, you would go through the array and you would count up the number of multiples of 3. Okay, so it's a 1 dot question. Who feels good about this kind of question? Who feels like no problem, I can do it really fast? Really? Only 3 people in here? Come on. this is like, come on, you can do this. This is an easy question, ish. Okay, so what will we do in this question? Yeah, well, you've done one. Let's have someone else. Come on, if you think it's, go on then. Yeah.
Initialize some count to 0.
Yep.
And loop through the list, and every time you get to a multiple, you
Yep. Okay, so let's do a count. We're going to make it equal to 0. Sorry, I'm not exciting on a Wednesday afternoon. Okay, and then we're going to loop through our array. So let's have a for loop. Int I is equal to 0. I is going to be less than size I++, which will allow us to move through the array. And then I want a condition inside my for loop that's going to check whether or not whatever is sitting inside array at index I modulus 3 is equal to 0, which means that it divides 3. And if it is, then I'm going to increase the count by 1. And then over here, I will return my final count. Okay. How's that? Good? Okay, let's try it out. Okay. Let's compile it. Okay, so it compiles fine, and if we look at the test array, it should give back 2, because there's 2 things that are multiples. So let's run it. And 2 are multiples of 3. So it's maybe working. I don't know. We could break it, no doubt. What would you test if you were in the exam? How would you test it? How would you change that array to test it? What do you reckon? Yeah. Sounds great. I would absolutely check a negative number in there. And if we run it, it's still working. And what about if we do a 0? I reckon that's going to give you something as well. Yep, so it's counting 0 as a multiple as well. So in your exam, make sure to look at the assumptions down the bottom of the question. It will tell you which numbers to not care about and which numbers to care about. And please make sure to look at them so that you don't spend time, you don't waste time in the exam. Okay, that's the one dot array hurdle. How do we feel? What about, actually I did want to do this one. Okay, another potential linked list question, which is the one dot array hurdle, is that you get given 2 linked lists, okay? And you have to compare them or do something with 2 linked lists, okay? So the code will look very similar, okay? But what will happen is you're going to have a little bit more here, and you're going to have a different way of making 2 linked lists now. You don't have to worry about it. We do it for you. But just so that you can see how to put it in command line so that you can actually see how you can test your function. Okay, so in this question, basically what's happening is you need to count up the number of nodes in each linked list, and then you need to do the difference between them. So let's say if you've got list 1, and list 1 has inside it 3, 4, 5, so it's got 3 nodes, and then you might have list 2, and list 2 has 5, 6, 7, 8, 9, 5 nodes, then you will have your difference function should return 2. Because one has 3 nodes, one has 5 nodes, the difference is 2. Okay, so the way that it separates them is by using a dash, which you will be told in the actual exam question in the spec. You'll be able to see an example of it running as well. You're given some sample how to test your function, but just so that you are aware of what's going on, let's quickly write it. How would you approach this question? What do you reckon? Yeah. Yep. How do I measure, how do I know how many nodes there are in a linked list? Yep. So I'll just basically traverse it, and then I'll count each of the nodes. Okay, so let's do, okay, so we've got, into this list we get given, into this function we get given struct node head 1 and struct node head 2. So I'm going to have a current 1, and it's going to be equal to head 1, and then I'm going to have a current 2, and that will allow me to keep track of where I am in the lists. Okay, and what I will do then is I will actually traverse the lists. So let's traverse the first one first. So whilst current, actually I need to keep track of how many there are. So I'll do count 1 is equal to 0, and int count 2 is equal to 0 as well. Okay. So whilst current 1 is not equal to null, would I go to null here, or will I do current next is not equal to null? And this is a super common mistake, especially when you're feeling the intense pressure of the exam. Yeah. Yeah, and why would I do that? Exactly. So I want to go to the current 1 not equal to null, because it will allow me to go past the end of the list, and it will allow me to count the last node in the list. Otherwise, I'll miss the last node. Okay, so whilst current 1 is not equal to null, I'm going to count my node, and I'm going to move myself along to the next node. Excellent. And then I will do exactly the same thing for my second list. Okay, so I'll do the same thing, and I've already made a mistake. That should be current 1, and that should be current 1, and that should be current 2, and that should be current 2 as well. Okay, and then for my final exciting adventure, I'm going to subtract them from each other. What can go wrong here? Oh, it could be negative, couldn't it? How do I account for that? Yeah. Yeah, perfect. I could do that, and that would be a really nice way to do it. I'm feeling really, really lazy, so I want to do something faster. What can I do faster? Who knows what I can do faster? Sasha's super lazy. Go on. I could use absolute value function, which is exactly, so either one works in the exam, okay? You don't have to use an absolute value function if you don't want to, but I would like to. So I'm going to use it, so then I'm going to be lazy and use the absolute value function here, which will give me the absolute value of whatever that subtraction is. Yeah. Talk to me. Where am I? Oh, I am too, yes. Trying to subtract lists from each other. How awkward is that? That would not have gone well. Yeah. So you're saying you only need, I mean, you could, but much faster to just, there is a way to do it. Let's just try this out, and then we can, but there is issues that could potentially occur. Okay, let's just try it out. So I'm going to compile it first. Okay, great, it compiles. So now when I want to run it, the way that I separate, just a little bit longer, please. Okay, 3, 4, 5. The dash is what separates the two lists in our code. Okay, that's how we will make the two linked lists. So that's going to be my second list, and then I'll run it, and it's going to give me 2. How would I try and break it? How would I test it? What would I do? do 2 empty lists? Is that what you're saying? I like that. So I'm going to do 2 empty lists. I'm going to do nothing with nothing, and nothing with nothing will give me 0. And the reason for that is because both of my counts here are 0. I start counting at 0, which means that it will just kind of skip all of this because they're equal to null, and it will go in there straight away. Anything else? Yeah. Love that. Okay, let's try that. That's not where I was. Let's do 1 empty list, and then let's do the next list with some values. Yeah, that was a good one. And then I'd probably swap them around to make sure it does it the opposite way as well. Okay, how are you feeling about the first hurdle question? How is everyone's thumbs up, thumbs down? A few thumbs up, excellent. I just want you to see that there really are like feasible questions to do, right? There's no kind of craziness in it. And I'm just trying to think of what I wrote for this exam and whether I went a bit crazy. Sometimes we do get overexcited, but I don't think it was this time. I hope not. Okay, now for next week, okay, before we finish, I want you to tell me what kinds of questions you want to do. And for some reason, I decided to exit the Kahoot, which is quite annoying. It's amazing spelling here. It's not a proper Kahoot. I'm sorry. It's just literally, I want to know what kinds of questions you want me to do next week. You can use libraries in the exam, in the questions. You can use whatever libraries you want, as long as the question doesn't specifically tell you not to use a specific library. So for example, some strings questions, it will tell you do not use the strings library or you will get 0 for this question. So please make sure to read that information. Can you do a question 11 next week? Oh my God. Maybe. Often our question 11s actually take longer than the whole exam to do. I just wanted to put that out there. Sometimes it's possible to do it. Most of our tutors can't even do it in the time allocated. You will not be able to search up libraries. But there are people that can do the question 11s in time. I swear it's not just a random situation. Don't worry about question 11. Why is everyone so hung up on question 11? Don't worry about it. Okay, let's do it. You tell me what you want to do. How long would I spend doing the exam? That's a really weird question because I wrote the exam. I should hopefully be able to answer it. I did have one of the tutors write the last question, and it's a really nice one this term. And Tammy wrote some of the debug questions. They're also really nice. I don't know why I put a time limit on it. Oh, that was stupid. Oh, well. Oh, that is an awful, awful poll. There's so many equal things. Okay, command line arguments and strings. Excellent. Harder linked list. Okay. Who else is the winner? Debugging type questions. We can do a few of those. Mixture of hurdle type questions. Okay, so basically no one wants to do simple linked lists. I feel you. Okay, today was enough, I guess. So next week, let's do some harder linked lists. So we'll do like a question 3 and 4, and then maybe we'll have a look at like a question. It's a waste of time to look at a question 10. We'll spend half the lecture doing it. I'll think about it, but we'll do some harder ones, and we'll do some of the question 3, 4, and then we'll do some debug, and then we'll do a whole bunch of Hurdles. Do structs inside structs. Okay, great. Yeah, we've got a lot of time to revise because I've not hit with 2 public holidays. All right, we're going to finish up there for today because I'm cooked. I have a headache, and I hope you have a lovely rest of the week. Good luck for your assignments, and enjoy your marks, which are being released at 6 o'clock.